Hello, and in this video, I'm going to set up a piece attribute that will allow the pile tool to pile up objects that are made up of multiple pieces of geometry. Now, currently, we only have one object, but it'd be nice to have a variety of different objects. So let's start by merging these two files together. Right, let's add a color to these so they're more easily distinguishable. There we go. So we've got two logs here, and they are coming into our input and then onto our copy to points. But if we take a look at our copy to points, you can see they're currently each asset has been copied to each one of the points, and we don't want that. We want to randomly copy either one of the models to these points. So to do that, we're going to use a piece attribute. And we can generate a piece attribute using a connectivity. So let's add a connectivity and put that after our input. So this node, it's created an attribute called class, created it on the points. I actually want to set it to primitives. And that attribute is an integer. So if we come over to our geometry spreadsheet and have a look on our primitives, we can see here we've got a class attribute, and here it says 0. Scroll down, value of 1 here. So if a primitive is connected to another primitive, it will share the same integer, for instance, a value of 0, and then if it's separate and not connected, it will have a different integer. So this way, we can tell Houdini that these are two different pieces of geometry. We can visualize the attribute if we come up to this visualization button, right click, next to scene is a little plus icon. We can add a visualization, and we want to add a marker. And let's name this class, and the attribute we want to visualize is class. And as soon as I do that, you can see we've got some numbers appearing on our geometry. Just going to transform one of these over so we can see them. And there you go, you can see we've got 0 on this log and a value of 1 on this log. So Houdini can tell that these are separate bits of geometry. We can delete that now and just disable that visualization. And if you come up to our copy to points, now need to use that attribute. And you can see on the copy to points, there's an option here for a piece attribute. Let's just check this icon. And the piece attribute we're using is called class. But it's looking for this piece attribute on the points. And these points don't have a piece attribute just yet. What we need to do is take the piece attributes on our wooden logs, randomly assign them to these points, and then this copy to points node will be able to assign the matching piece of geometry to the matching point that have the same piece attribute. So we're going to add another node called attribute from pieces. So the first input it requires is the point cloud. So that's from our scatter and align. And the second input is our geometry library, which is the geometry that has our piece attribute on it. And now, if we just turn that visualization back on and come up to where it says piece attribute, we want to select class. And now you can see we've got those that piece attribute appearing on our points. And we've got a few different modes to choose from here. There's cycle, patches, noise. We want to select random, and then we can disable that visualization and attach these points to our copy to points. And on our copy to points, we can now specify that class attribute. And there we go. Now we've got a single log on a single point. Now currently they're all orientated and facing the same direction. So on our scatter and align, under orientation, let's increase this max random cone angle to, say, 10. And currently they're all facing the same direction, and I want to flip some of them. So some of them are kind of facing the opposite way. And if we just come to our scatter and align, make that visible, and turn on display normals, we can see they're all currently facing in the same direction along the z-axis. So we want to flip some of these normals. And to do that, we're going to use an attribute randomize. Under attribute name, we want the attribute to be normal, like that. The operation we want is multiply. And for distribution, let's change it from uniform to 2 values. And what we're going to do is randomly multiply some of these points by either a value of 1 or a value of -1. When we do that, we get some of them flipped and facing in the opposite direction. And let's have a look now at our copy to points and just disable and re-enable this node. And currently we can see it's not having any effect. And that's because this copy to points has a few different ways of aligning these wooden logs. It can use an attribute, it can use a normal attribute, or you can use an orient attribute. And currently, this scatter and align node is outputting an orient attribute. As you can see here under the attributes tab. If we disable that, you'll now be using that normal attribute instead. And so now you can see that attribute randomize is now having an effect. Now this connectivity node generating this class attribute on every connected piece of geometry works okay in some instances, but if our model like this is made up of several different pieces, let's see what happens when we use this node. So let's add a color to this as well, just to make it easily distinguishable, and add this to our merge. And look at our copy to points. And you can see it's kind of exploded this model, because of course this connectivity node is assigning a unique integer to these bits of geometry and then copying these geometry to these points. And so you can see here we've got an integer on each one of these points, and it's copying those separate pieces to these points. So what I want to do is, with our tool, is be able to have a few different ways of specifying the kind of piece attribute you want to use. So before our input, on our file nodes, I'm going to add another attribute called name. So drop down a node called name, and so here's creating an attribute called name on primitives, and this is a string attribute. Come over to our geometry spreadsheet. On primitives, you can see here we've got that name attribute now. If we type in here, we can call this wooden log underscore 01. We can see now we've got that name here. So let's do that for all of our different assets. And we can also visualize this attribute as well. Let's add another marker. Call this name, attribute, name. And there we go. You can now see we've got those attributes visualized. Oh, let's do one, not wooden log 03. Let's call this chopped wood 01. And let's use this one is called wooden log 02, wooden log 01. So rather than using this class attribute, I'm going to use this name attribute instead. So after the connectivity, let's add a switch. Oops, let's disconnect that there and add this input here. Now, how we want to deal with this is, this is the user input, and then this goes into our digital asset. And there are a few different common names for piece attributes. One of them is name. They're also commonly used called piece or class or path, and the user might want to use any one of these alternative names for this piece attribute. So what we're going to do is allow them to specify the attribute that they want to use. When it comes into our tool, we're going to use a unique attribute that will be unique and only used within our digital asset. That way, it won't accidentally conflict with any pre-existing piece attributes that the user might be using or that a different node might generate within our digital asset. And that piece attribute, I'm going to call it underscore pile underscore name. So we're going to use name attribute, but I'm just prefixing it with the name of our digital asset. If I had a longer name, then I could maybe use an abbreviation of our digital asset. This will work for our needs. So rather than this piece attribute being called class, it's now called pile underscore name. And we're going to want to update that. So let's change that to pile name, and on the copy to points piece attribute, it needs to be underscore pile underscore name. Let's just disable our visualization. It's a bit overpacked, but let's just reduce this scatter line density to say 4. Oh, currently we're getting an error, and that's because on this connectivity, we want to change this from an integer to a string. And that will give it this prefix here. Just go piece underscore and come over to our geometry spreadsheet. You now see we've got that piece attribute here, followed by a unique number. And now if we come to our copy to points, select par name, there we go. So this mode will work okay if we've got geometry like this, where we've got objects that are whole pieces. This will work as intended. And then if the user wants to, they can specify their own piece attribute, such as name, and then we can have an option where we swap and use that piece attribute. And what we're going to do then is have a swap attribute swap. And we're going to take their name attribute, which is on primitives, and swap it to our internal unique piece attribute called pile name. And there we can look at our copy to points. There you go. Now you can see we've got each one of our models copied to our points. So this will give the user that uses this tool some flexibility on how they want to use that piece attribute. Now I'm just going to disconnect this third model example for now. Let's re-increase the scatter density to 10. Oh, actually, something we need to change on the way, now that we've changed the way we're assigning a piece attribute, we need to come up to the copy to points. And because they're currently working as kind of one whole object, what I want to do is on the copy to points is check pack an instance. And now when we run the simulation, now it's working as expected. Now when geometry is packed, it behaves a little differently. So these are now instances rather than copied geometry. And if we turn on wireframe and display points, you can see I've got a single point at the center of each one of these objects. And I can't edit this geometry directly. For instance, I try and select some points. I'm selecting these internal points rather than the geometry itself. And also, if you look at the geometry spreadsheet, you can see also the attributes we've got on this geometry also gets packed. It's no longer visible and no longer editable. But what we can do is unpack the geometry afterwards and then we have access back to this geometry, and I can now directly edit the geometry as well. Now, the advantage of using packed primitives is that they use far less memory. So if I had 100 or 1,000 objects, I'd get much better performance than if they were copied. So what I'm actually going to do is, after this time shift, is add an unpack here. So once our simulation is complete, we can return the geometry back to its original state. So now, after the grid, I want to add a taper. And I'm doing this because what I want is to have my geometry not this kind of uniform box shape. So with the taper, let's just reduce this taper here, and nothing's happening. And if we just show our gizmo, you can see that's because this taper is pointing in the z-axis, but our grid is in the x and the y. Let's just change the direction here of the capture direction. So put 1 in y and 0 in z. There we go. Now it's pointing in the right direction. Although our gizmo is currently not aligned to our geometry. That's because we need to set our capture length to make sure it's the right size, and also set this origin. So let's use some expressions again. We can use that centroid expression. And again, we want 0 for the first input, which references our grid, because that's what we want to find the center of. And we want to use the x-axis. Oops, I'm doing it in the center, so I want the y-axis. Let's do it for x. And then the z channel as well. Well, actually, we can actually see now the gizmo, we don't want it positioned at the center here. We want the bottom of here, the y to be positioned with the bottom of our grid. So let's change this centroid expression to an expression called binding box. So type b box, open brackets, 0, comma, and we can see 0 for the first input for our surface to reference. And here we've got a few more options. We can grab y min, y max, or either the top or the bottom, or the y size, which is the distance between them. Here we want y min. Oops. D underscore y min. And then for the capture length, we can also use that same expression, but this time we want it's d underscore y size. There we go. Now our gizmo for our taper is aligned to our grid, and then if our grid changes size, position, the linear taper will automatically update. Let's taper that a bit more. Take a look at our copy to points. Now we can see we've kind of got a bit more of this kind of pyramid shape to our pile. And when we run a simulation, we get a bit more of a bit more interesting shape. If things kind of explode like this, that's because we need to come up to this bullet solver and click Reset Simulation. There we go. And now our simulation has been reran, and the time shift is updated. Now, we've created this attribute here called pile name that we want, again, we're using that internally. But externally, when we want to output our geometry, I want to restore that name attribute so that the user kind of has it back as it was when they input the geometry into our tool. So to do that, let's look at the unpack node and look at the geometry spreadsheet. We can see we've got this underscore pile name. I'm just going to add another swap to change it back to this name attribute here. So let's, after the unpack node, add an attribute swap. And the source, on the class to be primitives, and the source is par name, and the destination is name. So that now we want to change the method from swap to move. So now that's removed the underscore name and is maintaining this name attribute. we're going to give the user the option to leave the geometry packed if they wish. So if we take a look at the time shift before the geometry is unpacked and look at the geometry spreadsheet, you can see we've got a name attribute here already on the primitives. And that's because it's coming from this bullet solver simulation. As this is an example of where other nodes are using a piece attribute that might conflict with an aim attribute that's already been created. But you can see, if we come over to points, we'll actually see we've got that underscore pile name here on points. And this was transferred to these points on the copy to points node. So what we're going to do is add an attribute promote, and I want to take pile name and promote it from points and move it back to primitives. So now it's on primitives. And then we can use the attribute swap here as well to swap that pile name back to name. And let's add a switch here so that the user can select whether or not they want to have the attribute packed or unpacked. So now we have a more robust way of dealing with piece attributes, and the user has the ability to specify their own custom piece attribute if they wish.